Hello and a very good morning to all the viewers. Today we are going to move on to understanding presentation of data in the form of graphs. We have spoken about numerical summaries earlier, wherein we talked about calculating mean, mode, median, standard deviation, range, variance, coefficient of variation. Today we are going to look at how to use a graph or a chart to summarize a given data set. So let's begin with understanding what is graphical representation. When we talk about display of data, we have two types of methods. Essentially, we can put the data into tables in the form of numbers and can present it, or we can have graphs, also known as charts, to present this data. What are the advantages of using graphical representation? Let's have a look at it first. If you have to look at differences, similarities, patterns in a given data set, you can easily make it out with the help of charts without having to go through large numbers. As I said earlier, when you're analyzing a set of numbers, you can make out differences and similarities by looking at these differences or similarities in a graphical format. And last but very important is, if you have a lot of data, you represent it using a graph, it can be quickly gone through, or it can be quickly seen, and all the patterns, differences, similarities, everything can be seen quickly by using a graph. Next, before we move on, we need to just have a quick recap of what we have seen earlier, that is types of data. So essentially, we need to know about this because using the right type of graph for presenting the right type of data is the challenge when we talk about summarizing data. So quickly, let's look through what are the types of data which we have seen earlier. The basic types are quantitative and categorical. Under quantitative, we have two varieties: continuous and discrete. When we talk about continuous variables, as you can see examples here of blood pressure, height, weight, and age, we have a unit measurement for each of them, and they can have decimal points within in order to be labeled as continuous variables. When we talk about discrete variables, we are talking about whole numbers. So the examples like number of children, number of attacks of asthma per week are examples wherein we have a whole number, but it is still a quantity, and that's why this data is classified under the quantitative type of data. The second variety of data is categorical data, under which we have two subcategories. One is known as ordinal category, in which we have grades, or we have degrees, or we have assessment scale like better, same, worse, disagree, neutral, agree, and there is an order to follow. So that's why this type of data is known as ordinal. And the second variety of categorical data is known as nominal. Nominal, in which we have examples like sex put in categories like male, female, or we have categories like alive or dead, blood group O, A, B, AB. So these are examples of nominal data. When nominal data is presented only in two categories, it is called as dichotomous data. So in this particular example, if you look at sex, it is a dichotomous kind of data because it has got only two options or two categories. So that's essentially understanding what are the types of data. Now we are going to move on to looking at what are the different types of graphical display. But before actually moving on to it, we need to look at what are the characteristics of a graph, or what information should a graph be able to give us. As we all have heard about this, a picture is worth 1,000 words. So if we have a picture, we have a diagram, we have a graph, it should help us in understanding the interpretation simply, without use of words or without use of numbers. So that's what is essentially necessary when we are looking at a good graph. So whenever we look at presenting data in a graphical format, please do remember few tips which are very, very essential in order to convey the information to the people who are your audience or people who are going to read your information. So the first thing is, the graph needs to be kept as simple as possible because it is required to convey information easily or readily to the person who is reading it. If it is a too complex graph, then what is the purpose of presenting it in a graphical format? Next, what are you presenting in your graph has to be explained through the medium of an appropriate title. So the title should be able to give you the variables studied in the graph or the type of data which is seen in the graph. When you are presenting categorical data and you have more than 2 categories, we need to use legends to tell us what is being depicted by a particular color or a particular pattern which you are showing in the graph. So these are few prerequisites which we need to keep in mind before we go on for a graphical display. So let's look at what are the different types of graphical displays which are commonly used in practice. There are several others which are not displayed on this slide, but I am going to cover only those which are more commonly used as compared to the others. So what we are going to look at today is pie charts, bar charts, histograms, scatter plots, stem and leaf plots, and box and whisker plots. So let's begin with pie charts. So a pie chart is a very simple and a basic form of graphical display which is useful for displaying categorical data, especially nominal data. So if you have a variable like sex in which we have 2 categories, male and female, or you have levels of education, you want to have 4 categories of levels of education, you can use a pie chart. A pie chart is essentially a circle which is divided in sectors, and the area under each sector illustrates the relative magnitude of one category as compared to the other. So what a pie chart gives us is a ready breakdown of a particular variable or a type of data into groups so that we can easily look at the distribution of data in that particular group. So we can know what is the maximum or the minimum, which is the least or which is the maximum. The area of the circle or area of the arc is going to give us the relative magnitude or frequency. So greater is the area, higher is the magnitude. Let's look at it with an example. So this is a pie chart which shows direct causes of maternal mortality given by the World Health Organization in 2010. From this pie chart, what we can see is there are 6 different direct causes of maternal mortality which have been represented here. And what has happened is in this particular pie chart, we see the maximum proportion of direct cause of maternal mortality being depicted by hemorrhage. So numerically it is 35%, and if you look at this arc or what we call as the area under each sector, this is the highest. So this is the most contributor of direct cause of maternal mortality, whereas sepsis in this particular depiction stands to the least, that is 8%. So the area covered by this sector also is proportionally lesser as compared to this one. So as we can see, we can have a quick glance at what are the different direct causes of maternal mortality and what are the relative proportions of these. If you total up all these proportions, it should stand up to 100%. So the total area in the circle is 100%, and then it gets divided according to its relative magnitude. So that's about pie chart. If we want to compare 2 different variables, a pie chart is not an ideal graphical display. What do I mean by that? We will use a better display like a bar chart in order to take care of this issue. So what is a bar chart? A bar chart is a graphical display used for summarizing a set of categorical or discrete data. Now in a bar chart we have various bars which we also call as rectangles because they will have the length greater than the width, and each rectangle is of the same width in a particular graphical display, and each bar is going to represent a particular category of the variable. Length of each rectangle is proportional to the number of cases or frequency of the cases in the category which it represents. Bar charts can be either displayed horizontally or vertically. And the most important thing to differentiate between a bar chart and a histogram is that in a bar chart, there will always be a gap between any 2 bars in that particular bar chart. And we'll look at it with an example. So here we have a graphical display of body mass index categories of 184 medical students. So we have 4 categories of body mass index which have been made here: underweight, normal, overweight, and obese. What is done is the length of each of these bar in each of the category is going to give us how many people out of 184 fall in that category. So as per this bar chart, we have on our x-axis the body mass index in categories, and we have the number of medical students or number of participants in your study along the y-axis. From the chart, we can see here that maximum of, that is 77 or 42.1% of this group of students lie in the overweight category, whereas the least is underweight, 7.1% or 13 out of 184. Here you can see that we can see either numbers and or proportions depicted in a particular format in this bar chart. So you can, when you total up the percentages, it should stand up to 100%, because this body mass index has been made into 4 categories, but it is taking an overall estimate of this 184 medical students body mass index. So it will stand up to 100%. Now, if you look at this bar chart, in this we are only studying one variable, that is body mass index. We can have several diseases or several types of illness being presented in one bar chart. So as you can see here, this is a graph showing you a global burden of disease. So you have several infections and their relative proportions, which is given. This is a horizontal type of a bar chart, wherein the conditions are given along the given vertically and the numbers are given horizontally. So you can know the least and the most common conditions contributing to global burden of disease. This is what I said, that when you have more than one variable, you can have a comparison when you use a bar chart. And this is the very commonly used what we call as a population pyramid, or a bar chart which shows the age and the sex distribution of individuals. So here we are comparing two variables, one is age and second is sex. So you can see in this graph that the males here are represented by green color and the females by the red color, and both are put across along a single vertical line, and along the y-axis we have the different age group categories, and we are trying to compare the number of females and number of males in each age group category. So this is a composite record of the age-sex distribution of populations, and that's why it is known as a population pyramid. So the point to remember here is, if there is a question asked about population pyramid, we need to keep in mind that population pyramid is nothing but a type of bar chart, wherein we are trying to compare two variables, that is age and sex. Now another example of a bar chart wherein we can compare the proportions of males and females here in a particular category. So here if you look at, you have two variables, level of education and sex, being compared with each other in a bar chart. Earlier I mentioned that a pie chart wouldn't help us do that, but a bar chart gives us an advantage that we can have a comparison of the proportion of males and females in each category of according to level of education. So for example, in the illiterate category, we can see that 30% were males, whereas 70% were females. Now in this kind of bar chart, which is also known as a stacked bar chart, each individual bar will make up to 100%, as you can see here, because the male females taken together should contribute to 100%. So out of the total males and females, 30% are illiterate. Here 70% have primary education, the males, whereas the females have only 30%. So each bar then gives you a total of 100%, which is opposite to what we have learned earlier when we talked about only one variable like BMI being depicted in the bar chart. So this is the advantage of a bar chart over a pie chart of depiction of more than one variables, more than one categorical variables. Next, let's move on to what is a histogram. Histogram is a way of summarizing data that is measured on an interval scale, or what we call as the continuous type of data. Now histogram will give you relative frequencies or absolute values, and it is divided up the range of possible values in the data set into classes or groups. So what we do is the relative frequencies are captured according to the groups or classes, and for each group a rectangle is constructed with the base length equal to the range of values in that specific group. Generally, we will take equal ranges. So what happens is, if you look at the base of the histogram, the width of the particular rectangle or the base length, what we call, is equal for all the rectangles. And vertically, if you look at, the area will be proportional to the number of observations or the frequencies. I'll try to explain using the following graph. Now let's look at this graph. This is a histogram which is trying to show the weights in kilogram as compared to the relative frequencies. So if you look here, the weights have been made in intervals of 1 to 1.1, 1.1 to 1.2, 1.2 to 1.3, and so on. Now, why don't we have separate bars, or why is there no gap between the bars? The reason is because in this particular case, weight, which is a continuous variable, has been captured in that way. What do I mean by this? When you consider the class interval 1 to 1.1, what happens is the entry of 1.1 will not be there in this category. The entry of 1.1 will be in the category labeled from 1.1 to 1.2. So anything less than 1.1 will enter in the category 1.0 to 1.1, and that is why we have a histogram which depicts this continuous data with no gap between the rectangles. So this is the basic difference between understanding a bar chart and a histogram. A bar chart is not used for representing continuous data, whereas a histogram will not be used for representing discrete data or categorical data. So that's the difference between a histogram and bar chart. There is another example here you can see wherein measurements have been made and their frequency has been checked. So if you look at the class intervals, it is 0.5 to less than 1.5. So anything which is less than 1.5 will be included in this category, as I said earlier. But 1.5 until something less than 2.5 will enter into the next category, and so on. So what a histogram shows us is the shape of distribution. So how is the type of distribution, whether it is a normal distribution or a skewed distribution, can be quickly seen by looking at a histogram. And how do we do it? If you join the midpoints of each of this bar and you join them, we put up something known as a frequency polygon. So what is a frequency polygon? It is nothing but joining the midpoints of bars of a histogram to create what we call as another line diagram, which makes a frequency polygon. In the x-axis, you have again the categories of data given there, or what you call as your continuous variable made in intervals, and the y-axis you have frequency of the data in each category. So as I said earlier, you take the midpoint of each of the bars on the histogram and then you can have a look at how it progresses. Now, what is the advantage of a frequency polygon over a histogram is that you can use several frequency distributions to be shown in one graph, which we cannot do using a histogram. So what we can check is, we can check whether two or more distributions are similar or dissimilar in nature. So let's look at an example. So here you can see this is a frequency polygon for age distribution. Why the word histogram is written over here is, if you try to visualize that these are rectangular bars whose midpoints have been taken, it is nothing but a histogram. But if you take out the bars from there, you are left with what we call as a frequency polygon. And you can compare more than two frequency polygons in one graph, as you can see in the next graph here, wherein you can see males and females being compared on heart rate variation, okay, with deep breathing. So as the heart rate varies according to the deep breathing, we can compare it for males and females. The males are represented by a dotted line and females by a continuous line. So this is a frequency polygon wherein we can compare two categories or two groups of people for the same variable. What is the use of a frequency polygon? So as we saw earlier, when you have too many points to be plotted, you can use a frequency polygon. Or if you have several series of information to be compared, like we saw that males and females heart rate variation to be compared in one graph, we can have a look at it. The best use of frequency polygons is what we call as time series, or when we are trying to look at the movement or the progression or regression of a particular disease or a condition, we can use a frequency polygon. So we are interested more in movement, whether there is a decline or an increase, and not actual frequencies or actual amounts. The point to remember about frequency polygon is you can draw multiple lines in a single graph, you can plot them and you can consider the trend. However, it is always better to limit the number of lines to 4. So it should not be more than 4 or 5 when you're trying to compare, because if you put too many lines, then it will be more difficult rather than simplified for comparison. So that's about frequency polygons. Let's move with scatter diagrams now. To depict the relationship between two continuous variables, we use what we call as a scatter diagram. Please do remember that scatter diagrams are not used for depicting categorical data. You need a continuous or a data which is measured on a ratio scale in order to put on a scatter diagram. These variables cannot be nominal in nature. The first variable is called as x variable and the second one is y variable. X variables is generally represented on the x-axis, that is the horizontal axis, and the y variable on the vertical axis. So these scatter diagrams are used to identify what we call as a correlation or relationship of two variations or two variables. By plotting the scatter diagram, we can identify either a positive correlation, a negative correlation, or no correlation at all. In the scatter diagram, we need to remember that we can have only variables measured on a ratio scale. So let's look at an example here. If you have a data containing one sample of individuals, so you have a group of individuals and you measure in each of the individuals in the group weight and height, and you want to compare the weights and heights of each individual in that particular group, we can plot a scatter diagram to depict the same. And how do we do it? What you do first is draw the horizontal axis with the x-axis with the predictor variable. What do I mean by predictor variable? You want to check whether a change in the height changes the weight. Okay, so whether weight is dependent or weight is the outcome variable, that's what we are trying to look at. So our outcome variable will come along the vertical or the y-axis. So what happens is, for every individual in the group, you will have a common point or what we call as a single point to mark for weight and height. And then you will have, for example, if you have 50 students, you will have 50 such points onto the graph or onto the diagram. And then what we do is we mark the two measurements as a single point for all the individuals and try to look at the correlation. So if you look at this particular scatter diagram, what do you see here is height along the x-axis and weight along the y-axis. 62 medical students undergoing this study. You can see, if you count the number of dots on this particular scatter diagram, they have to be 62 in number. And then if the number of dots are clumped together around this line and in the direction in which it goes, we call it as a positive correlation. Next, we move on to a stem and leaf plot. The next two graphical displays which we are going to look at today, that is stem and leaf plot and box and whisker plots, are not ideal graphical displays. What do I mean by that? Generally, when we present data in the form of a paper or an article in a journal, we prefer not to use these two graphical displays. The reason being, stem and leaf plots and box and whisker plots are generally used for what we call as exploration of the data, to look at how is the shape of the distribution of the data, how is the spread of the data. So we generally will, if you use statistical softwares, these particular graphical displays will come along the function what we call as explore, because we are trying to explore our data by using any one of these displays. However, let's learn about what is a stem and a leaf plot. To explain the stem and leaf plot, I am going to take this example. Let's look at marks obtained by 30 students in an examination. Now we have marks, that means we have 30 entries for this particular data set. How to make a stem and leaf plot out of that? So what we do first is, we have the digits here as, these are 2 digits in one particular number. So the tens figures are written in the left hand column of the diagram here, which are known as stems. So how do we do it? We draw a line here. On the left hand side, we have the digits which are in the tens. So the minimum here is 4 and the maximum here is 8. So we arrange them in an ascending order. So all the digits in the tens will come to the left of this line, which we call as the stems. And then what we do is, for all the digits in the units, we will go through each of them and then we will put them in the proper row. What do I mean by proper row? I'll show you now. These are known as the leaves. So the digits in the tens form the stem and the digits in the units will form the leaves. So again, we have, if we have to mark 63, where do we mark them? It will go here, 8 will go here, and so on. So if we have all these numbers here, 63, 61, 58 has already been represented, and so on. When all the marks are entered in the diagram, it will look something like this. So you can see here that this represents nothing but 40, this represents 44, and so on. So in all you should have 30 entries. Now this stem and leaf plot, if you look at it, you can know what is the maximum frequency here, what is the shape of the distribution here, whether there is a particular number which is pulling the distribution to one side, whether there are any outliers or extreme values. All this can be seen by looking at the stem and leaf plot. Now what we didn't do earlier and we are doing now here is, this is not arranged as per ascending order in the leaves section. So this can be easily done by rearranging them. So you can see that now they have been arranged in an ascending order on the leaves section part as well. Okay, so utility of the stem and leaf plot. Informative display definitely gives you an overview of the data. It will give you, what we say about stem and leaf is that it gives you a table because there are numbers in that, as well as a picture of the data. If you look at the data carefully, you can see the distribution of the data in that particular stem and leaf plot, because we have written all the data in an order of magnitude, from increasing to decreasing or from decreasing to increasing, whichever is preferred. And this is very, very useful for many statistical procedures. So please do remember that stem and leaf plot will help you organize your data to show its shape and the distribution. So shape, what I mean by shape is whether it is a normal distribution or it is type of skewed distribution, or it is being pulled to one side, either of the sides. Okay, so that's about utility of the stem and leaf plot. Last we move on to box and whisker plots. Box and whisker plot is a graphical display in which we have centrally located what we call as the box, and there are 2 whiskers, one at either end. Now these 2 whiskers basically give you the range of your data. So the spread of the data can be seen by looking at the whiskers. So the upper whisker will give you the maximum value and the lower whisker will give you the minimum value. Now when we look at this box in the center, this box again has got a line here somewhere, and this is what we call as, each of these lines of the box are known as quartiles. So I'll explain what quartiles means. Let's first have a look at this diagram. If you look at this particular middle line, it is known as your median. The lower one is known as the first quartile and the upper one is known as third quartile. So logically, median becomes your second quartile. And these 3 quartiles will divide your entire data set into 4 parts. So we will look at all the details of a box and whisker plot here. So what is a quartile? A quartile is a value that divides the distribution of data into 4 equal parts. So what we do here is we identify the points below which we have 25%, 50% and 75% of the distribution, and these are nothing but our quartiles. Please do remember your median is the second quartile. And if you want to look at the variation of the data shown by a box and whisker plot, you can calculate what we call as the interquartile range. Now this is different from what we call as range, because if you remember, I said earlier that range will give you the difference between the maximum value and the minimum value of the data set, whereas the interquartile range will give you the difference between the first and the third quartile. So if we look at our box and whisker plot here, interquartile range gives you the difference between the third quartile and the first one, whereas range will give you the difference between the maximum value and the minimum value. What is a box and whisker plot used for? It is used to show the shape of the distribution as well as the central value. Central value is nothing but the median, as well as variability around the median. All this is seen through a box and whisker plot. So the point to remember about box and whisker plot is that it is based on medians. We do not take the mean into account when we are talking about box and whisker plot. Now, box and whisker plots especially are helpful in indicating whether the distribution of our data, the shape of the distribution is whether it is skewed, and secondly, whether there are any unusual observations in the data set. What are unusual observations in the data set? They are known as outliers, which are values which cannot be captured within the range of the box and whisker plot. And box and whisker plots also display the degree of dispersion or spread of the data as well as skewness. What do I mean by spread is, if you have a box and whisker plot wherein the range is, you have the box and whisker plot which is very much elongated, and you have the two whiskers away from each other, you can see that that particular data is highly dispersed. Whereas if the box and whisker plot are stout or they are very short, you know that the distribution or the dispersion of the data is not to that extent. And it also shows us the skewness in the distribution. So if it is pulled towards one side, you can know that some of the data is trying to pull the distribution to one side. What I talked about outliers, you can see here, these circles here which are outside the range of your whiskers are what we call as outliers. So these are the outliers which can be easily identified using a box and whisker plot. So to summarize what we have learned today, before going on to make any graphical display or before even going on for data analysis, identification of type of data which we discussed like quantitative or categorical is the first and the most important crucial step. We saw that data can be displayed either using tables or graphs. Stem and leaf plots and box plots are used for exploration of the data, and they provide us an overview of the data as well as help us in identifying maybe errors or outliers or extreme values in the dataset. So that's all from me today about graphical summaries. Please do keep watching. Thanks for subscribing, and do subscribe. Have a great time.